So here we go with a question about arithmetic sequences. And it looks like it says arithmetic, but it's arithmetic when it's talking about sequences. And we're deciding, is it even a sequence? Like, is this an arithmetic sequence? If it is, what's the common difference? What's the 52nd term? We have 1, 2, 3, 4 terms here, and we have to go all the way to the 52nd. There's got to be a shorter way to get there. And the explicit formula. So there's like an explicit formula and a recursive formula. And so we're going to look at what all of that means. So determining if it's arithmetic, the first thing I want to do is subtract, get the difference, because arithmetic means it's adding something, or which could be a positive number, or if it's decreasing, it could be a negative number. And so I want to subtract these numbers and see what the increase is from negative 13 all the way up to 87. And so if I do 87 minus negative 13, we know minus is plus, right? And so I'm going to see what the difference is there. When I add that, I get 100. Okay, interesting. Well, what's 187 minus 87? This one's a lot easier for me to kind of think through. Well, that's going to be 100 as well. Same thing. And then 287 minus 187. Yeah, that's going to give me 100 as well. So I found a couple of things already. Is this arithmetic? The answer to that question is yes. And find the common difference. The difference here, we might say D equals or CD equals is 100. Okay, so the difference is 100. It's increasing by 100 every single time. And so to get to the 52nd term, think of how many times we'd have to do that. That's not practical. And so the formula is actually what I want to find next, because then I can just plug into the formula. Very, very straightforward in that situation. Okay, so let me slide a couple things over. I'm going to put myself down here. And I pulled up the formula sheet that's in your dashboard. And I'm trying to see where it is here. Okay, so it's in your dashboard, just under Algebra 1 Resources. It's right under that main heading right there. So if you don't already have your formula sheet downloaded, you can grab it there. And so at the bottom, you'll see under linear, we've got arithmetic sequences, explicit, recursive. Now the directions here ask for explicit. So this is the one that I want to use. So I'm going to go ahead and write it over here. Yeah, I'm going to do that. Let's go to a different color. So it says A sub n equals A sub n minus 1. Nope, I'm pulling from the wrong one. Let me fix that. I thought, oh, that doesn't sound right. A sub 1 plus n minus 1 times d. Okay, so right here, that's what I grabbed. A sub n equals A sub 1 plus n minus 1 times d. Okay, so now I can move that off the screen. Okay, so let's take a look. What in the world does this mean? All right, this is saying the number for any number in the sequence, like for the 52nd term or the 100th term or whatever term we're looking for. N is any number. A sub 1 means the first term. So that makes sense, right? The A sub 1 means the first one. So the first term. So the first term in this sequence was negative 13. So I am going to have A sub n equals negative 13 plus n minus 1 times d. We just found d. D's 100. Okay. All right. So we're almost to the formula. I mean, this is the formula. It's just not simplified. We don't ever really see this written this way. Think about when you see distributive property, you almost always see it written 100 times n minus 1. You always see the number in the front, and that just makes more sense to us because we're used to seeing it that way. So I'm going to rearrange it to make this a little bit easier because it's not super easy. So let me make sense. Okay, I brought down the negative 13. I flip-flopped this to make more visual sense. So now I'm going to distribute 100 times n. I know that's 100 n. 100 times -1 is -100. Okay, let me bring down the -13, and that's a positive. Okay, bring down the a sub n. Almost there. Now I have -13 and -100, and we can combine like terms, right? So our formula is a sub n equals, when I add those together, I get -113 plus 100n. And that's the explicit formula for this particular sequence. It only works for this sequence. So when I look at that, I've answered this question now. That's the explicit formula. And now I can use that to find the 50-second term. Okay, so we're just going to go here, and n is 52 because we're finding the 50-second term. So I'm going to plug into the formula. I've got -113 plus 100 times n, and we just said that that n is 52 because it's the 50-second term. All right, so let's clean that up. 52 times 100 is 5,200. That's a positive number. So if I subtract those, I'm actually going to get 5,087. I don't just know that. I haven't already figured out on another sheet. So anyway, yeah. Okay. So that's the answer to the 50-second term. If we continued adding 100 every single time, we would end up at 5,087 for the 50-second term in the sequence. Whew, that's a lot. It really is. It's a lot of things to think about. None of it's terribly hard. It's really just one of those things that you just kind of want to practice it several times. Once you've done a few of them, they just kind of click and make more sense. But I do hope that that's helpful. And remember, don't let anyone think less of you because you're young. I'll see you next time.